So this talk is called Tactical Exploitation. The point of this talk is just to go over different ways to break into things that rely just based on logical vulnerabilities. In other words, we're not exploiting some new zero-day. We're not talking about some new technique. So if you're here waiting for us to go drop the zero-day, we're not gonna. So you might as well go somewhere else. But if you're here to see new ways to pen test and kind of different techniques we found over the years that were useful for breaking in, and just kind of some nifty footprinting stuff, you're in the right place. So go ahead and start. Who we are. My name is H.G. Moore. I'm the Director of Security Research for Breaking Point Systems, and we provide network test equipment, and I lead the security team there. I'm also the founder of the Metasploit project and one of the core developers.
I'm Val Smith. I'm one of the founders of Offensive Computing, a malware research site, and I'm a contributor on the Metasploit project.
So why should you bother sitting through this thing? This is a pretty long talk. We've got 75 minutes for the first piece and 75 minutes for the second piece. The first section is really focused on discovery tools, techniques, probes, kind of nifty new tools, nifty new techniques. The second half is all about busting shells. So you may find the second half more interesting, but hopefully the first half will be useful as well. This talk is about a different approach to owning stuff. It's not about, do I have the latest zero-day, do I have the latest exploit? It's about looking at what your target has and abusing what they have to get a shell. And the nice thing about that technique is that it doesn't matter what patches they have applied. And we'll give an example of busting shells on a fully patched Windows XP Service Pack 2 system a little bit later in the second half of the talk. So lots of fun techniques, lots of fun tools, and it's all, real-world tested, mother-approved stuff that we've actually been using for the last 10 years. So first off, what do we cover? The first section is about target profiling. Just figuring out what do they have, how does it work, where are they hosted, who actually owns this machine, how do I get access to this machine, what network is this machine on, just different kinds of discovery tools and techniques. The second half is all about actually how do you break in, and once you break in, what do you do once you get in to get further access?
Okay, so vulnerabilities are transient. They come and they go. Sometimes O-Day works for a little while, then it goes away. So really, if you want to be effective at breaking into networks, you want to target the applications that you know are going to be there, the processes, especially the people who are in these target networks that you're going after. The trusts, there's trust between networks, trust between machines, trust between user accounts. Targeting the trust will almost always get you somewhere on a network. You will gain access.
A quick note for the folks who are looking along with the materials, these aren't going to match. Sorry. But we had a deadline for slides and we met it, but we also have much better slides now. So the new slides will be linked. The new slides will be linked off Metasploit.com later on today, probably tonight. So if you want to copy the latest materials, it'll be online there. So I think we can't get too close to each other. Or we set off some kind of alarm. All right, kidding. All right. So yeah, the slides will be online later on tonight. So if you're following materials and have no idea what the hell we're doing, that you're right. Don't follow the materials. So first off, crackers are opportunists. If you're doing a pen test and the bank manager or the corporation manager that you're talking to says, all right, you can break into these 5 servers, but not this one. Well, that's kind of unfair because the guy who's sweeping your network trying to bust shells, he doesn't give a damn. He's going to break into whatever the hell you have. It doesn't matter whether he's got a permission letter or not. And our point with this stuff is look beyond whatever the scope of the test is. If you're doing a pen test and the pen test is, start at 1001 and do that /24, great, but also look at other ways to get to that network besides going through that explicit IP space. So just because that 100/24 is in your scope doesn't mean you can't email a user who may have a workstation on that network. For example, look at other ways to get to that network, other ways that are in scope in some form, but through a different technique, through a different method. And of course, anything you don't actually test, someone else is going to, whether your customer wants to or not. So make sure they know about that when they put restrictions on what your scope is.
So hacking isn't necessarily about exploits. Exploits are a tool. They're one of the things you use when you're hacking networks. And depending on what you're doing, the target maybe ought to be the data rather than just getting root shells. In some cases, having regular user access is better than having a root shell because it's less monitored, less logged, less watched, and gets you access to the data that you really care about, whether it's financial data, trade secrets, depending on what you're going after. So this sort of method for hacking is using what you have available to you outside of your whole exploit framework, whether it's passwords, trust relationships, authentication systems, service hijacking, all that kind of stuff. So security is in many ways a people problem. People will write your software, people use the networks, target the user. The user is the problem, the sysadmin, the manager. Identify the meatware first. So there's lots of different ways to identify this. All the old ways, like Google News Groups.
All right, I'll go into this a little bit. So a friend of mine named Roloff, who hopefully was here today, I'm not sure if he's actually talking or not, but he has this really, really cool tool, and I'm going to blab all about it because I think it's awesome. Basically, if you go to Paterva.com, they've got a web demo, and they also have the GUI demo of that, and the link for it's up there. What this tool does is it does information discovery. So you give it one piece of data, like an email address, like a full name, like an IP address, a who is, a website, a domain name, any one single piece of data. It'll go out and find everything related to that data and put in this really nifty little GUI and let you crawl through it all. So, for example, if you give it, let's say, Jeff Moss, it'll go through and find all of his Flickr pictures, all of his Facebook entries, all of his blog entries, his email address, his PGP keys, his websites. And then from the interface, you can just click on the website and say, find more, do more transforms. And it'll go out and find everything else about that. So this is actually one of my favorite tools right now for finding, okay, so I've got this little bit of data the customer gave me. How do I go out actually finding everything else they own? How do I find out what networks they have access to? Is this guy active in a mailing list? Does he have personal servers in place? Getting that type of information is useful using tools like these. And SensePost had a tool called BittyBlah that's part of that, and they also have another tool for discovery. But I really prefer Evolution from Paterva, Roloff's tool. It's excellent. So these tools give us the full name, the username, the email address of whoever you're looking for. They can also give you their employment history. You can find links to their old email addresses in different companies, support tickets and news groups, all sorts of fun stuff. This is your standard kind of like open source information discovery, and it's kind of old hat to a lot of folks who do pen testing, but the services that the Paterva tool and other tools are actually querying now cover a much wider bit of information that we used to have access to. For example, before, news groups were really it for finding out where people were, where they worked, their employment history. These days, there's 15 billion social networks. There's all these different professional networks like LinkedIn. There's picture galleries. There's all these Web 2.0 fuzzy wombat services, whatever you want to call it. There's all these basically huge databases where people will sign up and willingly go provide all this great information about themselves, and this tool will go through and put it all together for you. So without hopefully stealing thunder from Roloff's talk, if he's doing a talk this year about it, check it out. And here's an example of what happens when you look for HD more. So for example, at the top you can see it actually got my phone number. So one off the bat. So if you ever want to call me and annoy the crap out of me, you can get my number through Paterva. You can also find my email address, the fact that I spoke at FOSDEM, some other stuff, the month of browser bugs project. You can find a link to that. So it is a really good tool just for kind of coordinating all this different information. It found an email address that I haven't used since 1997. All sorts of things. So it's really neat. It finds a ton of good data.
Okay, so I'm going to talk about sort of a case study of using this kind of information. We had a target on an engagement we were going after, and all we had to start off with was the company name and what the company does and the sort of job descriptions that people have. We knew we were after a specific type of data, so we started drilling down into that information. We discovered the company had an online personnel directory. This gives you things like email addresses, phone numbers, where their office is located, what group they work in the company. Once we got this, we started getting clues as to who are the people who were likely to have access to the data. Using some of these people's names, we started browsing the web. We found their resumes. They say, oh, I work in this area, I work in that area. Email addresses. So in many cases on large networks, someone's email account is the same as their username. So like Joe at company.com, when he logs in, he's logging in as Joe many times. So the email address is the target. So to make this a little more personal, our target in this case was Joe Targetstein, and he worked as a lead engineer in this firm that did semiconductor research. So we discovered his email address on the company directory and started doing some searches on the web and some news groups. In the old days, a lot of times people's computers, their email would come from joe at joesbox.com. This gave us a hint that, well, maybe the host that he's still using is Joe's Box. So now we have a username and a host name to target to begin our attacks. We know based on his resume that he works in the area of data that we're interested in, so he probably has access.
So that's personal discovery. We're going to go really lightly for a lot of different discovery categories. And so this isn't meant to be a, how to do open source research or how to find information. This is just kind of a general idea of how we go from basically knowing nothing about the target to popping shells internally. And so it may be a little bit slow at first, but as we get into it, you'll see how all this stuff kind of ties together. So the next stage after personnel discovery is figuring out what the target assets are. So given a company name, given a username, given just some guy's first name or last name, how do we find out basically what service he has access to? And we're not talking about just his whois block, his ASN information. We're talking about third-party servers, hosted servers, outsourced email services, spam gateways, all those sorts of fun things. There's a whole lot of really good tools for that. We're not going to go into too many of those. But there's a lot of tools that are just lesser known. For example, this is what people use all the time. There's whois, Google, zone transfers, DNS lookups, just kind of your standard old stuff. What we like to use, because it's, number one, less visible to the target, but two, much more effective these days, is other people's services. So we use the new shiny new hotness, which is abusing someone else's server to find out information about our target for us. And we do that through tools such as centralops.net and Digital Point.
Yeah, so these sorts of sites basically are web services that do the work for you. Like CentralOps will get you a dossier on your target. You give them a domain name or an IP address, and they will come back and say, oh, this IP is owned by this company. This net block belongs here in this country. The host name is owned by these people. In some cases, you can actually get what ports are open for a limited set of standard ports. And this is all stuff that you're doing from their computer, not from your computer. So when the target looks at his logs, he's going to see them, not you. So it'll throw him off the trail. Digital Point does great DNS zone transfers. And you'd be surprised. I mean, that's like, I don't know, 15 years old, but it still works all over the place and lets you find sometimes hidden hosts that you didn't know about, other targets to go after.
Some other tools, I've already mentioned Viterva, which is on the slide, but there's a website out there called Domain Tools. And I hate to plug a commercial service like this, but they're actually useful. So what Domain Tools does is one of the things they offer is anytime a domain is registered, they're a registrar, so they get that information. So what they do is they do a DNS lookup of every domain that gets registered. They find out where that domain is hosted, and they put it into a big-ass database. Then they put a key on that IP address. So they can actually search for the database saying, okay, what domains are at this IP address? So now you get a list of every domain hosted on a given IP. And that's really useful because it means you don't have to go out and figure out what virtual hosts are on an IP, what personal domains are registered to it. You can just basically go to this website, look it up, and be done. So kind of a fun example of that is going against defcon.org. So we can see if you look at defcon.org, on the same IP address that defcon.org resolves to is also darktangent.net, which is Jeff Moss's handle, defcon.net. And defcon.net is a little bit interesting because it actually resolves to more than one IP. So one of the IPs it resolves to is the same server as defcon.org's IP, but it's not the only one. And we'll go to another slide here in a second. There's also Hacker Jeopardy, which we all know of, and it'll actually be the end of today. That'll be in DEFCON, sorry. Hacker Poetry, which I hope to God no one ever actually creates as an event here, or I might put a screw through my head. So nothing offensive against the poets in the room, but don't keep your day job. I've seen some really bad hacker poetry. All right, so just in case you weren't sure who the Dark Tangent was, you can also go to thedarktangent.com and .net.org. So let's go back to that defcon.net example. In this case, that domain actually resolved to two different IP addresses. One of them was actually shared on the defcon.org server. The second one was on this other box. And for the sake of Jeff and Ping, I actually didn't include all their other domains, but they have a bunch of really fun ones, like republicofping.com, things like that. But some of the domains on here are like zeroday.com, zeroday.net, darktangent.org, securityzen. So if you ever really wanted to go register zeroday.com and you couldn't do it, you can go blame Jeff now. Like, dude, you took zeroday.com. You're not even using it. What are you doing? Come on, man. So, anyways. So it's a great way to basically find out what other hosts are on a given target. So if your target's, let's say it's a bank, and you want to see whether they're hosted with an ISP or not, and you can't figure that out via whois, like it's a large network block, you can go to domaintools.com, dump this thing into it, and it'll tell you how many of the domains are registered on the same site. And the thing to keep in mind is if more than one site is hosted on the same IP address, every one of those sites is in your scope. Just because it's a different virtual host doesn't mean it's not on the same server. And your target is the server, not that virtual host. So you could say, okay, on zeroday.com, there's actually a really cool bug I can exploit, but on the main target, defcon.net, there wasn't. So keep that in mind when you're doing pen tests. Make sure you always test the virtual host, because just because the bank's virtual host is locked down doesn't mean someone else's isn't. So what does this get us? We get proxy DNS probes, zone transfers, virtual hosts for every IP address. We can get port scans. We can get traceroute information. Just a gold mine of really cool information that other people are doing for us. We don't even have to put our IP address into any of their logs. So in addition to these kind of like third-party discovery techniques, there's actually some really cool tools you can use, more so techniques than tools, for finding information about a target network. For example, one of my favorites is actually just triggering SMTP bounces from the target network. If you don't know anything at all about a company except for what their domain is, just send an email to it. Just say, hey, Bob, and hopefully there's no one named Bob actually there, but you can call it like bob.something or a username that looks innocent, but it's really something you know won't exist. So send an email to that domain, look at the bounce messages coming back, and you can often determine the internal information, such as the name of the mail server they use, the internal IP address information. I'll go to an example of that here in a second. You can also brute force the vhost of an external web server. So something I see again and again is companies who will actually put their intranet site and their internal administration site on the same physical web server as their external site. And they just set up the vhost. So when you go to www.mybank.com, it serves up my bank. But if you tell it to that web server in port 80, you do get/http/1.1 host:/intranet and hit enter a couple times, it'll give you their intranet site. So don't forget about that stuff when doing pen tests. Just because the IP address, the host name in the vhost table isn't documented anywhere, try all the common ones like intranet, www, admin, things like that, and you'll find all sorts of fun things. A good example of that is Internet Explorer, Internet Information Server. So the ASP scripts that are installed by default in IIS will actually look at what the host name is and provide different data depending whether you're a local host or not. So if you do a GET request for a default IIS install for the default.asp, normally what you get is, there's no site configured here, click here to learn more about IIS, things like that. However, if you connect to it and you do host:/localhost from an external IP, you're not localhost, it'll actually give you the local start page. So a lot of times scripts are actually intelligent about what host name you're requesting and will give you different responses. So even if the website you're going to only has a single virtual host, try passing host:/localhost to it and see if you get a different response. A lot of times people do things like set up PHP error messages. So when you're local, it'll give you those error messages. But when you're not local, it won't. So keep that stuff in mind. Another way to figure out what the network is like and what software they use, what their addressing information is to send them an email from a subdomain where you control the DNS server. So create a new fake subdomain. Call it, mydomain.metasploit.com. And now send an email to them from bob@mydomain.metasploit.com. What happens when that email goes in and you send it to a non-existent address and tries to bounce back out, the internal server will then do a MX record lookup for your subdomain. And in doing so, it queries whatever its DNS server is. And that DNS server in turn queries your DNS server. So by looking at that incoming DNS request and looking at the source port, the transaction ID, things like that, the pattern of transaction IDs, if you do more than one of these, you can determine what software they use and what DNS server the internal sites are actually using. And that may be completely different than the DNS server they use for external requests. So that's a case where we'll get more into DNS attacks later on, but an entry point for things like DNS cache spoofing, things like that. And worst case, just email the users and drop them a link. Be like, hey Bob, check out this website. And you can see where they come from. And if they come to you from some little cable modem in the middle of nowhere, they could be on a home network, they could be on a branch office, they could be in a hotel, but you still know where that guy is. So for example, there's this great company called RSA, and they're well known for their security. So much so that they registered rsasecurity.com. And if you send an email to an unknown host at unknown user at rsasecurity.com, you get this great little message coming back, which tells you exactly what software they use, the whole chain of stuff. I truncated some of it here, but you can see the internal IP address of the internal mail gateway. So anyways, it's kind of a fun example just because they talk about how great their products are and how secure they are. And most folks who actually do pen testing know how insecure a lot of RSA products can be, especially all the ACE stuff. And anyways, I won't go into it. But basically, here's an example of an internal IP of a real server, and it's probably still vulnerable now. I mean, it's their server, not mine. I'm not telling them about it. So finally, on to application discovery. Do you want to talk about this?
Sure. So if the network is the toast, applications are the butter. Every application that's available on the network is a potential entry point, whether these are internally written applications, these are commercial applications. A lot of times finding these applications is the trick to getting into a network that maybe isn't vulnerable to traditional exploits remotely. There's a lot of great tools for doing application discovery or service discovery. Everybody knows about tools like Nmap and AMAP, Nikto and Nessus. And there's a whole bunch of commercial tools which we're not going to plug here. But some things to think about is that doing your probes for application services slowly often will yield better results and definitely better stealth for your attacks. A lot of times just think about, rather than, okay, I want to know every port on every machine on the whole network, that's a ton of data to go through. Maybe you have a bug that you know works on a specific service. Scan for that one port or one service only on the network. A good example of this is this scan here for Microsoft SQL servers, one of my favorites during pen tests. And so rather than send pings across the entire network, scan hundreds of ports on all these different hosts, you're just going to find out the specific hosts that have that. And that gives you some other information, like most likely what the OS is. It's at least some kind of Windows. Okay, so in one case study where we use this kind of technique, the target had a custom in-house written IDS service. What this IDS sort of did was it detected when large numbers of connections were performed across the network. It wasn't necessarily an Nmap IDS signature so much as like too many connections to too many hosts, which is unexpected behavior on normal networks. So a standard Nmap scan would just light up alerts like crazy on this IDS system. So what we decided to do was, well, we'll do a slow scan, one port only, on a bunch of different random hosts, and the IDS never detected us. A lot of times you get information too, like if port 22 is open, in general it's some kind of Unix. If port 139 is open, in general it's Windows or Samba server some sort. So rather than doing these loud, noisy scans, just a few targeted things, tactical techniques, will get you a lot of information that's more useful. So drilling down a little more into this particular example, this one target had an internal app which we discovered by doing some of these slow scans. And what they used this app for was software licensing and distribution. So every host on this large network used this application to get their software. There are something like 10,000 nodes using this. So we managed to get a copy of the software, and rather than do traditional, let's look for buffer overflows, let's look for other types of exploits, we'll reverse it and just look for standard sort of configuration issues. Well, what we found was they had a static administrator password stored in memory when this application was run. So every host on the network had the same admin password for a period of time. By using this password, we were able to own every host on the network without using a single exploit, just by taking a look at the application services that were available.
Kind of the key thing about application discovery is that if you're looking for different applications in the network, you're scanning ports, and you find something you don't know what it is, you just find port 1523 open, for example, which may actually be something. If you don't know what it is, that's your job to go find out what it is. In other words, go look for any kind of copy of that application. If you can figure out what application it is, get a copy of that application. And that's where a lot of pen tests kind of fall down, is you find out that, hey, they're running some custom web server, and you can't find a copy of that server in the next 20 minutes. So you don't really worry about it. But however, if you actually go through the effort of finding a copy of that software, BitTorrent, Donkey, whatever you need to do to find a copy of that software, to bring it down locally, tear it apart, and find a bug, that's how you're going to get in. So the point with the pen test is to break in. That's all there is to it. So as long as you keep that in mind and realize that the only scope that really matters is whether or not you're in or not, in some cases, and what they can prove later on in the court of law, that's what it comes down to. So in this case, it was finding a copy of the application, tearing it apart, finding the password, and then using that everywhere. And every one of those nodes could have been patched, and you still got access to 10,000 shells. So it's really effective.
Yeah, if you're just relying on well-known commercial vulnerabilities, many times you're not going to get in. The network's going to be patched, and you're going to be out of luck. But if you expand your scope a little bit and look deeply into the custom stuff that people are doing, you'll find ways to get in.
So a little bit of application discovery. A tool, we're going to talk about a lot of new tools that came out in the last couple of months because I haven't seen much noise about them on the list, and I think they're really great. One example of that tool is W3AF, which is actually the acronym for Web Application Attack and Audit Framework. What this tool does is kind of like a Python version of Metasploit for the web. And that's a really ugly way of saying it. As a really cool tab completion command shell for doing things like directory brute forcing, finding virtual hosts, all the things we talked about earlier for finding information about applications and discovering custom applications, you can script using this tool for the command line. So like a lot of the best tools out there, it actually gets pretty heavy into scripting when you start extending it. Things like Scapy. This is kind of like the web version of Scapy for the folks here who have played with that. It's a really great tool, and I definitely recommend you get familiar with it if you haven't already, if you're doing pen testing for web apps. One thing I want to mention real quick is that Metasploit 3 has actually been extended to include what's called the scanner modules. And scanner modules are any module that includes the auxiliary scanner mixin. And what that gives you basically is you can write a really quick module, include the TCP mixin, include the auxiliary scanner mixin, and all you have to do inside your code is create a function called def run host. And inside def run host, you get an IP address, and if you do connect, it connects to a port, and it talks to it and does whatever you want to do. So if you find some custom application and you realize, hey, if I send these 4 bytes to it, I get back a version number, but you don't really want to go through all the effort of building a scanning framework for it and either writing in C or Perl or whatnot, and it's kind of a pain. You don't have to want to worry about having to set like doing CIDR mask parsing. I mean, all those different things that are part of most little quick scanning tools that are a pain in the ass to write, you can do just by using the Metasploit auxiliary format. And I'm going to pop off the slides real quick here and just show you an example of what that looks like. So first off, can anyone actually read the screen? All right, so let me try to make the font a little bit bigger. And that didn't work, so let's try that again. Let's see, Courier, console, something big. How about now? All right, great. So in the main directory, you can see there's scanner batch, scanner host, scanner range. Those are just example scripts that show how to either write a scanner that works off a single host at a time, a single range of hosts at a time, or a single batch of hosts defined by your module. And the neat thing about that is, even though it only works off one host at a time, one of the parameters that you get is the number of threads to run at the same time. So you can write a single host tool that basically connects to a service, sends some data, gets a response, stores it somewhere, but you can have it run against 1,024 threads at the exact same time. And you can use just basically normal stack routines, run as an unprivileged user, and quickly scan a huge network for a custom application. So don't let the fact that there's no tool out there for whatever application you're looking for keep you from running a scanner for it, or to keep you from finding similar information or similar data. The structure for it's really easy. We've got, the very top, some basic boilerplate saying, it inherits from MSF auxiliary, includes auxiliary module, name, information, options saying we take a port value. Excuse me, that is VI. Oh, Vim, all right. Got it. There we go. Now I know how to do that. Thank you. Hey, I actually use Nirvana Editor. I don't use VI or Vim. I'm one of those, I don't know if that's old school or new school, but I use a less TIFF-based editor still. So, anyways. So here we see we've got a little function that's 3 lines long called def run host, takes an IP address, prints out saying, hey, I'm working on this host. So pretty damn boring. So let's go look at a better example. Inside this directory, we also see there's a couple files called HTTP, MSQL, SMB, etc. If we look at the HTTP example of that, we have a version scanner, which is... See, look, I learned. All right. So you can see we include HTTP client mixin, we include the scanner mixin, in the run host function, which is kind of mangled because of the line wrap. But basically, we just do one call to send request URI/method get. You can see here, we don't actually set our host name anywhere. We don't actually do a connection call anywhere. That all happens for you underneath the scenes. So if you want to write a single host web scanner real quick, that's it. You just change the URI and you're done. And inside the console, you just do set our host with an S on the end of it, 10.0.0/24, set threads 256, run, and it has 256 threads, the entire subnet scanning for that URI, and prints it out. So keep that in mind. If you want to write a quick scanner module, there's a whole bunch of cool stuff already in Metasploit. For example, we've got the exact same version of that, but this version does a put request to the index file with whatever file you have in your local system. So folks who know what the put request does in HTTP, raise your hand. All right, great. So what this does, it works, you can still do 256 threads at once. You can still give it a whole subnet, and it mass defaces the whole damn subnet every time you run it. So if you're really lazy and they're running front page, that's one way to see if they're running front page. It also supports the delete commands. You can just delete the web root of every host in the local network. So it's an easy way to basically take some new code and scale that code across an entire subnet really easily. And let me get back to the slides real quick. Hopefully I wasn't too far off track. Let's see. Anyway, so you can use Metasploit scanner mixins to write really quick web app scanners and even any application scanner in these Ruby modules, and they're pretty much painless. And you can use the same console, same interface. You can use the GUI if you want, the web interface. They all work the same way. So that's I was going to do an actual demo, but I think we're going to run out of time if we do that, so keep on going. Client apps. Client applications are really cool because they're always exploitable and no one patches them, and they're the pain in the ass to track what versions are installed where. So you look at a browser and be like, all right, so I got this version of this browser installed. Am I vulnerable? Well, a whole lot comes into play. It doesn't matter what version of the browser you have installed. It matters what version of Flash plugin, what version of Adobe PDF Reader. It matters, do you have Java installed? And if so, do you have a version of the JRE runtime that's exploitable to the recent JNLP overflow? I mean, you can't just look at a single client application and say vulnerable, yes, no. So one thing you need to do is fingerprint what versions are installed, and how you go about doing this is through some of the techniques we'll talk about here. So common probe methods, just mail links to the targets. I mean, don't be afraid to contact the users at an organization. They get all kinds of spam every day in their mailbox. One more spam they don't really understand isn't going to make them that mad. There isn't that much business impact to getting a gibberish email. So keep that in mind when you're doing a pen test. Don't be afraid to contact the users. In the kind of security world, you see folks tend to be broken into two categories. The guys who are really good at social engineering but can't hack their way out of wet paper bag, and the guys who are really good at hacking out of wet paper bags but can't really talk to customers. And the bridge is getting crossed. People are getting better, and I'm meeting more folks who are kind of in the middle there. But you still have kind of that geek stigma of, I don't really want to talk to people. I don't want to actually deal with this person. And so try to get over that when you're doing pen tests, because that's where the easy bugs are, the people.
People are the bugs.
And
Squash them. Yeah, so, look at things like review exposed weblogs. A lot of times people will actually leave these up so that you can access them from web servers or other means. Send these MDMs to specific victims. This is where, have you ever got one of those emails that said, do you want to reply to let them know you received this email? Basically send them that, because that's a way to see what's going on there. Abuse email addresses like all@target.com, everyone@target.com. These will get you large numbers of people, and they'll be noisy, but you're going to get the information that you want out of them.
I mean, I've worked at 3 security companies, and every one of them has had an everyone or everyone or all email address that you can reach from outside. So it doesn't matter whether half the people on the list half the people on that distribution list are security people, the other half aren't, and you can still own them via really easy techniques. So, they receive spam to those email addresses. Make your email look like spam. I mean, you don't have to let them know it's you doing it.
Yeah, this is really great on large networks that have 10,000 or more nodes, because you're going to have subsets of the network that don't know any better, and they're going to respond to these. And so you're going to get, all you need is one foothold. Once you have a foothold, you can take over the rest of the network.
All right, the next section is about process discovery, and a lot of folks will go ahead and talk about, this vulnerability or this network layout or this structure or this configuration. What this is about is what your target actually does. It doesn't matter how they do it, what applications they use to do it. What you're trying to figure out is, what do they actually do? Do they do backups in the middle of the night? Do they transfer files from this web server to this web server? How often do they update their website? How often do they go into this directory and do these things? A lot of times you can actually find race conditions where every time, let's say 3 a.m. every night, they go through and delete the whole web directory and upload the files back in. But let's say the order they upload the files in, they don't include the .htaccess file first. So if you've got this tiny little window, you can bypass HT authentication. And we've seen that before, and there's different ways to actually detect that. So just because your pen test says, okay, we've got 2 days to do this, doesn't mean you can't run a 2-day-long, profiling attack against their servers. So one easy way to do that, which is becoming less prevalent but still lots of fun, is IPID. So a lot of IP stacks, anytime they send a packet out, they'll increment the IP ID in their internal counter. And anytime they send a packet to somebody else, that IP ID is then sent out with that. So it's just kind of a counter of how many packets that host has sent out, since it's basically booted, depending on what the initialization is for it. You can also look at things like the last modified headers. So Apache will send this by default, but they won't send it by default for active content. So if you're trying to figure out when the web root of a directory was uploaded, don't look at just the .html files. Just do header requests against the image files, and you'll see last modified tags on that. Those last modified tags are usually the time the page was uploaded. If you see a whole lot of those matching the exact same time window, and you see that over a couple of days changing, the day's changing but the time's not changing, congratulations, you just found a cron job. So now what you want to do is build a web scanner that runs, right between that window every night and see if it gets any different results. Is the web root there? Is there directory listing because they didn't upload indexed HTML yet? Is there a swap file there? Is there a temporary backup like the ones that rsync will make? Look for that type of data. Finally, there's things like FTP servers where they actually expose the statistics of how many times each command was run. And by profiling that over a couple of days, you can determine when the admin actually uploads files, when automated backups are performed, things like that. And here's basically what we just said. Look for patterns of activity. So when you're looking at the IP ID of a server over a period of time, look at how it changes during the day. So during the day, between 9 and 5, when all the worker bees are using it, you'll see a pretty high level of activity for the most part. especially for web servers, mail servers, things like that. However, in the middle of the night, especially around 8 p.m., all the traffic from U.S. customers drops off. And if you're in Europe, this may be different. If you're in Asia, this may be different. But apply that to your own local time zone. What you'll see is a much lower amount of traffic between, let's say, 8 p.m. and 6 a.m. However, a lot of times when you do this type of test, you'll see a huge spike right around midnight, which everyone's doing backup jobs. So this gives you an idea of when they back up their server. And this can actually allow you to find out how they're doing backups, a little bit more probes. We'll talk about that a little bit more in the next section. For example, FTP stats are also a great way to do that. We mentioned that before. But every Microsoft FTP server out there that now allows anonymous login, you can query that stat counter for each one of the commands. You just do type site stats, gives you a huge dump. And even Microsoft's own FTP server isn't invulnerable to that. And we'll give an example of kind of how many times people have logged in, things like that, using that command. And finally, we mentioned this before, but when you're doing profiling via last modified headers, make sure you check the timestamp of the images, not just the static content, because PHP won't return a last modified header. So are there any existing tools for this? I haven't found any yet. Does anyone know of one? All right. Well, I'm lazy. I just use hping, stick into a text file, and then grep it out with Perl or Ruby. And I'll show a graph in a couple slides up here, and that graph will actually is based on hping, a little bit of Ruby code, and I'll upload that as part of the materials on metasploit.com later tonight. You can use Netcat for site stats or any FTP client. It's not rocket science. So here's an example of Microsoft.com. And this is actually just one node of their FTP server cluster. And the neat things to keep in mind here are the commands in yellow, which are actually privileged commands. There may be a couple more I didn't highlight, but this gives you an idea of when they actually upload files to this FTP server. If you look over here on the right-hand side, you'll see the store command. And the store command is run 3,000 times since the server was booted, which, as we can tell from the banner, is 47 days. So within 47 days, they've done about 3,000 uploads. In the same time, they've removed 41 directories, they've created 870 new directories, and they've deleted 1,910 files. What this doesn't tell you is whether the command is successful. So you can actually skew these numbers by logging in and just doing a whole bunch of delete commands that the server ignores, but the counter will still get bumped up. One stat that I thought was really interesting was the user command. So in the last 47 days, there's been, 2 billion users logging into this server. And this is just one node of their cluster. So if you ever want to get a size for who actually still uses FTP, 2 billion people in 47 days. Or at least 2 billion connections. So let's see. I think we're doing good on time, so I'm not going to rush this stuff. Yep, we still have
You just like to do that one demo that you skipped.
Okay. Yeah, we've got a couple demos we'll go back into. We've got one more slide here, then we'll do a little bit of demos, and then I think our break is going to come up. So here's the website hacker.com. And I was like, well, what's a good website to monitor for this demo? And hacker.com looked like it'd be a good one. So what we did basically is just ran hping last night, sending a SYN packet to a port that there's nothing listing on. So the server kept coming back with the reset ACK. And I started this around 10 p.m. last night, killed it about 8 a.m. this morning when I woke up, got some breakfast, just Control-C'd it, and look at the text file. And I ran this through a little Perl script that dumps out just a little, data, basically, the delta between each IP ID, taking into account the 16-bit wrap, because it goes to 65535 and then back down to 0. And just looking at the delta of how many packets are sent per second, removing my own packet from that across this window of time. So at the very beginning, you can see down at the bottom, there's not a whole lot here. It's pretty light traffic. It gets a little bit spiky, but that's folks just downloading big files. But right around midnight, we see this huge spike in traffic, and that must be their automated backup. So there's an automated backup being running at the site right around midnight. It could be someone's shelling in and doing rsync. It could be their W getting something from another site. But we can see there's a big spike of activity at midnight, and then it gets really, really quiet all the way to about 6 a.m. And you can see this nice lull right here. And then right as the USA people wake up again, it starts to ramp back up. So this isn't a great graph. I did this whole thing in about 5 minutes with the Gruff library in Ruby. But it gives you an idea of how just running hping for 10 hours can actually give you really good information about a site. And this example, we know they do backups. We know they do something really big at midnight. We know when their site's most active. So if we're doing a pen test where we're going to take it down, we know when it's going to affect the least amount of users. So all this kind of information you can infer just by looking at how much traffic one host sends. Another good example of that is a VPN server. Just pinging their VPN server on 1723 of using PPTP. And check that for a while. And when you see that server going crazy with traffic, you know people are logging into it. So just similar techniques like that. These aren't groundbreaking. These aren't shiny or new or anything like that. But they're stuff that's really useful for pen testing and stuff that we wanted to share.
Yeah, it's sort of a different way of thinking about your target. Like let's say that they do a load every night of their payroll information on a certain server. Well, maybe you want to go after the payroll information. So doing these kind of techniques will get you an insight into the behavior of the network. How is it architected? How do the sysadmins work? When do big jobs happen? What machines are under heavy loads at what time? And you never know when this information is going to be useful to you breaking into a network.
Let's see. So we're great on time. We actually went a lot faster with this than we thought. But we have lots of stuff to demo, so won't be bored, hopefully. So also in the scanner directory, we've got all sorts of things like a vHOST brute forcer. Under the SMB directory, we actually have a scanner that'll go through and find the version number of every SMB server in the local network. Anyone here running Mac OS X? Anyone here want to? Okay, a couple folks admit to running Mac OS X. Did you apply that update last night? All right. So finally, after 2.5 months, Apple decided to patch Samba, and which is really annoying because we had this really good exploit for Samba. We just had it in Metasploit. So we're going a little bit more about that in the second half. But if you want to, let's say you're on the wireless network here, you've got a copy of Metasploit 3 installed, and you want to check out this auxiliary scanner stuff, and you want to figure out which people running Mac OS X haven't patched yet. One way to do that is on the MSF command console, do use space auxiliary /scanner /SMB /version. And then just do set our host to be the local subnet. Then you just type run. And everybody running Windows or Samba on Linux, BSD, Mac, etc. will come back and tell you what operating system they're running, things like that. The neat thing about this module is it actually goes a little bit further than just getting the remote OS. It'll actually figure out what service packet it is a lot of times. And these aren't that easy to read on the screen up here, but basically, oh, yep, sorry, syntax. I forgot the red is not readable. There we go. All right. So we look at this smb.client.purnative.os string, which is what the server sends back to us as we do a session setup. And inside this, we see NT40, 50, 51, 2003, just basic common stuff. Windows 2003 server is actually nice enough to tell us exactly what service packet's running. So Microsoft's getting better at telling us these things. We don't have to guess anymore. No more guessing what target to use for your exploit. It's like, yes, it's 2. Give me that. Thank you. Drive through. We see that continue down here. Windows Vista, exact same thing. They give you the full build number, the version number, whatnot. I mean, they're getting much better at being friendly to us hackers. So down here at the bottom, you see we look for Samba. And in the case of Samba, we actually pull the pure native LM. And it's kind of wrapped on the screen. But basically, what that'll do is it'll tell us the version of Samba that's running. And if you see version 3.0.10, that's probably an OS X box because Apple decided to stick with that version and not update it for like 2 years. So if you see anyone running 3.0.10, don't own them really quickly. Like, give them some time to apply that patch or something. Let's see, what other demos do we have? Oh, right. So Rollops tool, the Perturba.com interface. For the last couple of months, they've only had this web interface up there. And the web interface was neat, and it showed you things like when you search for Flickr, it actually used Ajax to show the Flickr pictures in a different window. So you search for like Jeff Moss, you actually get a picture of Jeff Moss right there. So it was really cool. It was like, hey, look, there's that guy, I know him. And so in the last, probably last week or so, they released a GUI version of that tool, which is all written in Java, and their backend's written in Java as well. And it's just full of a whole bunch of little transform files that transform an email to a phone to a name, things like that. So I can actually demo his tool, and hopefully he won't get mad for me showing it off before he's made a big noise about it. But it needs net access to work for the most part, but has a really cool UI. So I want to show off the UI real quick.
Yeah, when you're using a tool like this, I mean, let's say you come across some website that's got a picture of the target's dog. You never know when that's going to be useful. Maybe the dog's name is Buffy and his password's Buffy.
So if I had network access, that would actually work a lot better. But if anyone who does have network access, just go to Perturba.com. You can download the GUI client for it. So I basically dragged a domain over and then called it defcon.net. And at this point, to find all the information about defcon.net, you just double-click. Actually, you could right-click, and it has a big list of things you can find. So, for example, we can find the email address, the phone number, and any site information associated with this domain. Or we can find out just the email addresses, just the site, just the phone numbers, similar addresses, PGP information at that domain, things like that. Or just down here at the bottom, do all transforms. And one of the transforms that's neat is actually documents and files. This will actually go to Google and say, okay, search for anything on this domain, a file type, PowerPoint or doc and things like that. So it goes through all the legwork of finding documents on these servers for you, and that's why I'm such a fanboy of this tool. So, sorry.
Yeah, I've actually found sites where there'll be like an admin directory that's not linked anywhere, and inside the admin directory is a Word doc. You open the Word doc, and it's like, how are internal networks configured? The admin passwords are. look for the Word docs that the sysadmins are putting up thinking no one can find them.
So in this case, you see it doesn't really do anything without net access, but if you have that, it'll actually spider the whole thing out and creates this little graph you can play with in real time. Is anyone use the IDAPRO 5.0 or 5.1? Okay. Well, the folks who have, like two of them looks like, it has a cool interface for basically going from function to function using a graph. And it's got the same thing here for following nodes of information around. So if you find out that, Bob is a coworker named Jim, you can actually double click on Jim and then pull up the same information for Jim that you have for Bob. So you can keep actually just following kind of the web of trust or following kind of the links of associations. So you can actually do your whole 6 degrees of Kevin Bacon with this if you really felt like it. Search for Kevin Bacon and keep clicking and eventually you'll find your name in there somewhere. Hopefully. So that should work. I haven't actually gone that far into it so far, and I don't like Kevin Bacon, so I haven't really done that yet.
The trusts are the real points of weaknesses in a network or between systems. What people trust what people. Let's say you can't hack your target network, but you can hack his best friend's home network, and he happened to have given him a shell on his machine at work. Well, then you have a foothold through a different, it depends what the scope of your test is, but it gives you different footholds into a network that you wouldn't normally have if you're just focused on, this IP address range and nothing else.
Some other demos. So we talked a little bit about, emailing links to clients, and what you don't want to use for that is your own email client, because it gives away things like your user agents and things like that, and it's just not information you really want to share with your target. And it's not really the best tool for the job in a lot of cases. Recently, in the Metasploit framework, we actually added support for sending email directly from the framework. And for folks who've used like Core Impact, it's already a feature available there. I'm just going to give you an example of how you can easily use things like the ANI module and spam them out to everybody on the all list real quick and then get shells. I don't actually have a mail server set up, so I can't demo the exploit itself, but I can show you the module. And it's under modules, exploits, Windows, email. And here we've got some 0-day that you can ignore. And then we have this that I'm going to hide real quick. All right, 6 on, off. So we've got the way the Metasploit modules work is each module has a mixin, and the mixin defines what the API of that module is. So for the scanner modules, we just included the auxiliary scanner mixin, and then we included TCP or UDP or whatever we're doing. In this case, we're going to include the exploit remote SMTP deliver mixin, which basically provides functions for sending email into our module. In this case, we've got our absolutely huge ANI exploit, and it's kind of ugly to navigate through like this, but let me find the send email function. Send something, send mail, looks like, send message. All right, so one of the nifty things about how the ANI vulnerability worked is that when an error, the function that actually the overflow occurred inside of was wrapped by an SEH handler by the library. What that means is when an overflow occurred and you actually trashed the entire stack, the user never saw anything. It just kept on running. So just do, everything's fine, keep on going, not a big deal. So the great thing about that is you can actually brute force ANI images to get the right return address for a given target just by sending a whole lot of them, putting them all into one email message, and then referencing them in sequential order from inside an HTML web page by their content disposition ID. So it's kind of hairy, but basically the code for that ended up being create a web page. Inside the web page, let's see, where are we? Sorry, HTML. It's kind of ugly here. Basically, create a standard HTML template, a bunch of random gibberish inside of it that won't make much sense to the user. They'll open up going, hey, what the hell is this? Down near the bottom, you can see to create the actual message, we just do message equal rex mime message new, creates a new mime body. We set the subject based on what the user set or random value, set the to, the from. The mail server that you want to relay this through is actually automatically provided as an option. So you can relay it through their mail server, your mail server, however you want to do it. And finally down here, we add for each ANI image we want to include as part of the brute force, we add an ANI attachment type. And we give them random extensions. We give them like .bmp, .jpeg, etc. And the way we reference it doesn't really matter. We still get our shell. So that's it. And then you do send message and you're done. So if you want to send something that sends an MDN, the message dispatch notification stuff, to figure out who's actually there, where the email addresses are, where they come back from, you can use a Metasploit module like this under the auxiliary tree to send email for you and get those things back. So even if you don't really code very much, you can just grab one of these examples, copy it over, change like 5 things, and you're good to go.
One really great thing that large networks are doing is standardization. They're like, well, let's get everyone on the same OS, same patch level, same client. And I love that because that means that if I find one bug to get in, I can get it on every machine. And so, these sorts of ideas take advantage of that. Like, you can spam a whole network and get an idea of, okay, look, everyone's running this patch level or this client. They run Outlook for all their mail or whatever it is.
So here's another example. In this example, we're going to use the another auxiliary scanner module, but this one actually does discovery of hosts and does that by doing UDP sweeps. This is another example of you don't want to look for every single port, every single service. You only look for a couple things that indicate enough information about the target that you know whether you want to go after them or not. So this module will actually go through and look for things like DNS servers, NFS servers, RPC servers, SNMP, TFTP, all sorts of little UDP services, and it creates a single socket and spams it out to all these hosts as part of the target. I'm not on the wireless now, otherwise I'd show you what you're running, but right now I can run it against the virtual machine. So the syntax for this is just set our hosts with your target, and that's about it. If you do show options, we can see the batch size. So we want to work in blocks of 256. Our threads are set to 1 because we're already doing 256 at a time. It's not a big deal. And we just said run. And my VM over here should come back. See, it's awake. There we go. All right, so we see we discovered NetBIOS in this host. This is UDP only sweep. And one of the neat things about this module is you can set the source port of it to be another application that you know is allowed through the firewall or is less likely to be looked at by an IPS or an IDS. A good example of that is if you're trying to find every NFS server on the network, which is actually pretty common. You try to find NFS servers because they're wide open no matter what you do with them. A good way to find DNS servers without tipping off the admin that you're doing something is instead of querying for the port map service, the Mount D service, or one of those other services used to actually initialize it, actually probe the NFS server itself on port 2048. And when you do so, send your packet from source port 53. And if you configure the beginning of your RPC packet correctly, it'll actually look like a DNS reply. So it just blows past everyone's firewalls out there, and when you do hit a valid NFS server, it'll come back saying invalid version, invalid opcode, invalid handle, depending on what opcode you send as part of your message. So Val talked about it a little bit as far as ways to sweep through and find NFS servers and bypass IPS and IDS, and we'll get into more about NFS and fun NFS tricks later on. See, well, we've got a ton of time right now, and I hate to rush into the next section because we've got a whole bunch of really cool demos, but they're all kind of tied together. So you don't want to just do the first one and then not go to the next one because it's not that much fun. Any questions so far? Wow, were they really boring or? Yes, sir.
You skipped over demo earlier.
Sorry?
So you skipped over a demo earlier in the presentation. Let's go back and get out.
Okay. Let me pull that up.
Where did you say to find the slides?
They'll be on Metasploit.com later on tonight.
You get scanned out the list of
Sorry?
Are you going to post them on your mailing list if you post the slides and the materials?
Yes. So the question was, first thing was, we've got another demo we can do. I guess we'll go ahead and do that demo. Two is like, where can you find the slides for this? It'll be on Metasploit.com. And three, once we post it to the Metasploit.com website, will it be on the mailing list? And yes, to all of those, we will do it.
Oh, there's a question over here.
Just a comment, if you find somebody's got multiple MX records out there, you bounce the multiple MX records, sometimes it maps off internal IP structure of the network, especially if it's large.
It's a good example. So the comment was that if the target domain has multiple MX records, you can try bouncing a message off each individual mail server. And depending on how that mail server reacts, especially with larger networks, you'll get internal information back from one mail server, maybe not another one. So when you're trying this stuff, definitely try every mail server, not just one of them. And that's how you can actually specify the SNTP server command in the auxiliary module is one way to specify just this one mail server versus your local mail server, which will deliver it automatically.
So the second half of our talk after the break, while he's pulling this up, we're going to go really deeply into some of these subjects and show some demos of things like trust hijacking, SSH hijacking, Kerberos ticket stealing, leveraging NFS home directory servers to break into tons of nodes onto the network. So that's sort of a little overview of what the next half is going to be about. And some fun SMB stuff.
So one of the demos I was going to cover earlier, we actually already did. That was just the auxiliary UDP scanner. Unfortunately, the network isn't set up right, so I can't actually do the full suite. But that was a lot of fun. Another demo that we're going to go through, and we actually pulled it out because we didn't have enough time for it, is a different way to do virtual host detection. And a lot of times, if let's say you've got a big list of virtual hosts you want to try, and you connect to the web server, and you send / get / HTTP 1.0 host name something, and you get a big chunk of data back. How can you determine that that's a different virtual host from your previous virtual host? So if you have this giant list, a lot of times you can't tell. If you just do a byte for byte compare, that won't work because a lot of dynamic content will do things like show the latest user comment at the top, or there'll be banner ads being cycled into it. There isn't really a good way to determine this virtual host is actually different from this virtual host without visually recognizing that. So my solution to that, and actually what's going to be in Metasploit really soon, is you actually do the edit cost difference of each virtual host's web page. And for those who don't know what edit cost is, basically it's how many bytes you have to change in this body of text to make it equal to this body of text. So you get this nice metric out of it. Unfortunately, it's a really slow algorithm to run, so you only want to do it across about 200 bytes at a time at the top of the page. And if those match up, you go down to your next 200 bytes and so on. So the general technique for this, and there's a module that I'll implement most of it, but I think it's only about a quarter done in this module. Here's an example of let me turn off the syntax. So basically, we've got a list of virtual hosts we want to try, like admin, localhost, web, exchange, HR, things like that. And we're going to go down this list and do GET requests for each one of those. And actually, before we do that, what we're going to do is go to the main virtual host, the one based on the IP address or the main host name that we do know about this host, and we're going to take that page and get it 5 times. And between each of those 5 pages, we're going to compare the edit cost from that page to the page after and so on. In other words, how many bytes differ, how many bytes do we have to change, how many steps do we have to go through to make those pages equal. And for most sites, even if they have dynamic content, that number will actually be less than 20 or 30. In the case where a large block of text at the top changes, like titles and so on, it may be around 40 or 50. However, when you hit a different virtual host entirely, where the structure is completely different, that'll be in the hundreds. And so that's basically your metric, is you compare the edit cost, the average edit cost of the main page 5 times, and then you compare it with each of these other virtual hosts, and you see whether the difference is greater than or less than your average. And for the most part, you see something like 30 or 40 for the main one and over 100 for the next one, then you know you automatically have that. And this is actually more used for people developing vulnerability scanners than it is an actual analyst. But once we have this module completed, you don't have to worry about that. It'll just tell you. You give it a dictionary to go through and just brute forces the whole thing. But it's definitely a neat technique for doing it. Any other questions? Wow. Okay.
How much time do we have?
I think we're still. We got about 10 minutes left, and. Let's see. One thing we can do is kind of give you a preview of what's coming up. So you found this entire segment entirely boring. Hopefully the next one you won't. And this is kind of all our prep work to get us to the next section. So if this is boring, I apologize. We're actually going to much more exciting stuff coming up. And that's all basically driven to abusing Kerberos, abusing Secure Shell, popping shells on fully patched Windows boxes using fun techniques, things like that. But unless there's any questions, do you want to do previews or?
Yeah, sure.
Okay. Yeah, we didn't realize how fast we spoke, so at least I didn't.
We're excited about this.
All right, so the general idea with this, the next section here, let's see if we can get it. Actually, it's on the other slide deck. That's not the right directory. Sorry? Yeah, just covering what we're talking about next. So if you guys want to head out now, you can come on back in and
come back in a little bit.
Yeah, 30-minute break or so. The next section is actually really cool, so come back for that one.
Please.